All right, in this next part, we're going to talk about graphing polynomials. So the first three, we should really know what those shapes are. So if we have a constant, that's going to be some type of horizontal line. If it's linear, we are going to have some type of diagonal line. And a constant is a special type of linear function. Okay? But if it is a horizontal line, we call it a constant. If it has a slope to it other than 0, that's going to be a linear one. Quadratic is going to be some type of U-shape. And then the cubic ones is where we start getting into the new stuff. So we have no idea what a cubic equation looks like at this point. So just to start with, I want you to grab your graphing calculator, and I want you to type in y equals x cubed into y1. Okay. All right, so here is my graphing calculator. Let me make some adjustments here. Zoom in. Okay, so we're going to start by going to the y equals screen. So y equals, if you have something there, you just want to clear it. And then we're going to type in y cubed, or x cubed. And then I want to start in a standard window. So I'm going to press zoom 6 because I don't remember what my window was set to before this. Okay. All right, so here is our cubic equation. Okay. So it looks kind of similar to a linear equation because it has some type of positive slope, but it's not a nice straight line. So that's how we know we're dealing with a cubic instead of a linear equation. Now we do need to be a little bit careful because if we go back to the y equals, now I'm going to just go down to my second equation and I'm going to type x to the 5th. So graphing a quintic equation right now. And if I press graph, notice how it's almost tracing over the one that's there. Okay? And even if I go back, let's graph a 7th degree, so in our third equation, so x to the 7th. Okay. So again, it looks like they're really, really close. So any odd degree as the parent function for a polynomial is going to match this general shape. Okay. Now if we go back, and I'm going to clear out my y2 and y3, and in my y2 spot, I'm going to type the equation x cubed plus 4x squared plus x plus 1. Okay? So this is just another example of a cubic equation, and we're just going to compare it to our parent function. And remember, when I'm saying the word parent function, I'm just talking about the most basic equation in that family of functions. Okay, okay, so here's our parent function. And then here's the other equation. Okay, so notice that they're different, but the ends of it, so we call it the end behavior. So our graph starts and end, we call that the end behavior, is starting and finishing in the same spot. So I'm starting down in the negatives, and it's ending up in the positives. But we have this more of zigzag shape. So, and that's going to be true for all cubic equations. They're going to have some type of shape like this, where it's that squiggle. But it's never going to have more than 2 turning points. And the turning point is when our graph changes direction. So as we're tracing along this graph, so I'm tracing, I get up here, it turns around and our slope becomes negative. So this point up here, we call that a turning point. And this would be our maximum turning point, since it's at the top of a graph. And again, as I'm following this, it's going down, going down, going down, and then all of a sudden it turns around, so our turning point, and then our slope becomes positive, so now it's going up. So this point down here, that is another turning point, which we would call a minimum. And we'll talk more about those vocabulary terms in a little bit here. Okay. So but again, when we're looking at this, if I go in and change, so I'm going to get rid of both of these. And let's just try graphing x cubed plus x minus 8. Let's see what happens. Okay, so I got a slightly different shape. And I can't quite see it down here, so I'm going to go into my window, and I'm going to make my y minimum smaller. So let's try like negative 30 and graph. Okay, so it's similar to our parent function, but we still can identify it as a cubic equation. So, and even if I go back, let's go to our y equals, let's try something else. So let's just try x cubed plus 5x squared minus 1. And I'm going to go back to my standard window, so zoom 6. Okay. All right, so again, I'm getting a weird shape. I can't quite see it up here, so I'm going to go back to my window. This time I have to change my maximum, so I'm going to try 30 again. Okay, so now it's kind of following that graph similar to the second equation that we graphed for our cubic. So again, we have that S shape. We have no more than 2 turning points. It's starting and ending in 2 different spots. So that's how I know to identify it as a cubic equation, if I didn't know what the equation was. All right, so now we're going to kind of switch what we're doing. So back to the y equals. This time we are going to graph a quartic equation. So remember, that's a degree of 4. So let's just start with our parent function. So x to the 4th, and then zoom 6 to make sure we're in a standard window. So if we're looking at that, that actually looks really, really close to a quadratic equation because that's making that U shape. But we should notice down here that it's actually a little bit flatter on the bottom. Okay. So just to kind of emphasize that, I'm going to go back to my y equals, and I'm going to graph x to the 6th degree. And again, these are both parent functions. So again, it looks like we're almost tracing along that. So it's very, very similar. But again, it's a little bit flatter on the bottom part of that graph. So even if I try x to the 8th, same thing should happen. Okay, so again, very similar graph. Okay, so that means that anything with an even power for our parent function is going to make a shape similar to this. And notice how the end behavior, so our graph is starting and ending, is different from an odd power. So for an odd power, remember, we started down, ended up, or if we had a reflection, it would be the other way. But we started and ended in different spots. Well, with an even degree, we're going to start and end in the same spot. So even if I go back in, and I'm going to go down to my y to the 4th, I'm going to put a negative. Let's just do a squared, so x squared. So if it reflects over, then it's going to start and end down here. But it's still starting and ending in the same spot. So that's how, when we're graphing or looking at a graph, if we're not sure what the equation is, at the very least, we should be able to tell if it's going to be an even or an odd degree function based on where the end behavior starts and ends. So if it starts and ends in the same place, it's even. If it starts and ends in 2 different places, it's going to be odd. Okay. All right, so back to y equals. We are going to clear everything in the y2, y3, and 4 spot. And since we know what this parent function is, I'm going to actually clear this one too. And now we're going to type in x to the 4th plus 4x cubed plus 2x squared minus 2x plus 1. And then I'm just going to graph them. Okay. All right, so notice how there's more turning points in this one than our cubic equation. So we have 1, 2, 3 turning points in this. Okay. Now the number of turning points, the maximum number that you can have is 1 less than the highest power. So remember, this is a 4th degree, so a quartic. So, and we have 3 turning points. So we're never going to have more than that for this type of problem. So it's going to make kind of this W shape. So if we even go in and change it, so let's try graphing x to the 4th plus 8x squared minus 5. I'm going to graph it. Okay, so again, it's looking like a U shape, but it's not quite a U because it's not nice and symmetrical down there. So let's go back in and change it. Let's do maybe 3x to the 4th minus x cubed plus x squared plus 3. See what happens. Okay, so again, just another slight variation of that. So we could get something that looks closer to the U, or we could get something that looks closer to a W shape. So again, it just depends on the function that we're graphing. So each one of these terms kind of does its own thing to the graph. So even if we take one out, So I don't know, let's just maybe delete the cubic term, see what happens. Oops. Okay, so it changed slightly, but not very much. So even if we take out, let's take out this +3 here. So again, see what happens. Okay, so that one definitely moved our graph. So again, the graphs are going to vary a little bit based on the number of terms and what those terms are. Okay. All right, so let's go back to notes here. Okay, so we've filled in our constant, linear, quadratic. So our cubic, again, so our parent function. So I'm going to use a couple different colors here. The parent function is going to look something similar to this. And then as we start adding in our own things, we could see something more like this. Okay. And same thing with the quartic, so kind of our starting point is going to look something like this. But again, as we start adding things to it, so different terms, it could be something like this. Okay. Now again, the end behavior is just describing where your graph starts and ends. So we're talking about as it approaches positive and negative infinity. The turning point is where our graph changes direction, so your slope has to change from positive to negative or negative to positive. So when we're looking at this parent function, there are no turning points in it. So sometimes the graph will not have turning points. Sometimes it will have 2. Sometimes it could have 3. And again, our even degree, those are going to start and end in the same spot for the end behavior. So in general, this is talking about end behavior. Okay. If we have a positive leading coefficient for an even degree, it's going to start up, end up. If it's a negative, so a reflection happened, it's going to start down and end down. And then an odd degree is going to start and end in 2 different places. So if you can think of a linear function, so a positive slope on a linear function, that'll be the same for all odd degrees. So it's going to start down and up. And if there was a reflection, that means that it's going to start up and end down.